Okay, let's look at the graph we should have drawn from the last lesson. So if I zoom out a wee bit, I might be able to fit this all on the one screen. So we should have drawn a graph using our data with f to the minus 1, so 1 over f on our x-axis and L on our y-axis, and you should have got pretty much a straight line through the origin. Now, this is really close to the cutoff point for being able to not use the false axis. There's just about more than half of our data there if we start from 0, and just about more than half of our data there if we start from 0. You may have got a better graph if you decided that you would put these axes to kind of start at, I don't know, 1.5 on the x-axis and start at 15 on the y-axis. You may have been able to find a better scale, but you can get away with not just about in this case. So what we said was that the gradient of this graph is equal to v over 4. We want to find the speed of sound from this. So what we have to do is we have to find the gradient first of all. Now I'm going to pick this point because it looks quite nice to use for my graph, and I'll pick the origin as well. And if I do that, I get that the gradient is rise over run. Now the rise is 30, but that's centimeters, so I might be best at this point changing that 30 and dividing it by 100 and getting 0.3 meters. Just make my life a little bit easier later on. And then my run is 3.5. But if we notice our unit here, we made our life easier. We did talk about this. You may have not done it. It's okay if you didn't. But we took the by 10 to the minus 3 and the seconds out, so that we would end up with 3.5 by 10 to the minus 3 seconds. Now I'm just putting the units in there because it'll show where this comes from. So if we type that into our calculator, so we do 0.3 divided by 3.5 by 10 to the minus 3, it gives us 85.7, what just happened there? 85.7 meters divided by seconds, so meters per second. Now, if we then rearrange this equation, it gives us v equals 4 times the gradient. So our velocity will be 4 times 85.7, which will give us quite a good value. So 343 meters per second. Okay. Hopefully you did get a nice straight line graph for this. What you may have done is made a mistake somewhere with your units. So you may have found you got, I don't know, 34,000 meters per second, or 33,400. No, 34,000. So that probably means you didn't convert from the centimeters. If you're getting different values, you may not have included the by 10 to the minus 3 seconds that you can see my column is in up here. Now you may have just decided that no, I didn't enter them like that in my table. I did 0.00391 and 0.00329 and 0.00276. That's all right. Nothing wrong with doing it that way. It may just be harder to write those numbers and plot those numbers on the y-axis. So I find it easier taking that by 10 to the minus 3 out, and then we can plot nicer numbers. But you should have got a value close to that. Okay.